Mrs. Young again, back with part 2 of today's lesson. We're going to do one more word problem together, and again, I'll talk through it as if I'm thinking like a student and trying to solve the problem. First thing we're going to do is read through the problem and decide what words or clues or the question being asked, what parts of that tell us what to do. A teacher was mailing a gift to her favorite student. Is it you? Never know. She wanted to know if she had enough wrapping paper to cover a box that was 9 inches long, 4 inches wide, and 5 inches tall. If she had 200 square inches of paper, did she have enough to cover the gift? So again, like our last problem, we want to think about the different words that we're reading. I'm going to go back through and highlight some words that, to me, give me hints. A teacher was mailing a gift to her favorite student. She wanted to know if she had enough wrapping paper to cover. Cover tells me we're covering something, probably around the outside. A box that was 9 inches long, 4 inches wide, and 5 inches tall. If she had 200 square inches of paper, did she have enough to cover the gift? So the word cover and this word square tell me that we are looking for surface area. The reason I know that is because the word square talks about that area, that 2D shape. We're talking when we say square, something squared right there. That means 2D, or flat, or area. So we do have 3 measurements like in our last problem. So those 3 measurements could tell us volume because we use those 3 measurements, but those 3 measurements are also telling us the dimensions of a box. For example, this box here could have 9 inches long, 4 inches wide, and 5 inches tall. So what we want to know is if we're going to wrap that box, here's what the wrapping paper could look like. Okay, and this wrapping paper, we need to know how much of it do we need to cover that box. To cover that box up, how much wrapping paper do we need here? And since we are finding surface area of a box, we know from our work with surface area that on a rectangular prism, like this box, there are how many areas? 6, yes. There will be a top and a bottom, a left and a right, and a front and a back. Very good. So there are 6 sides. We are going to write down this box. We're going to say it looks like this. So the length of this front is 9 across times base times height, it gives us the area, times 5 inches tall. If the front is 9 times 5, which is 45 inches squared, then the back is going to be the exact same. Okay, we've got the side, the left side and the right side are going to have the same measurement. So over here, we said this was 5, this was 9. So on this side, we've got a width of 4 and a height of 5. So that side is 4 times 5, which is 20 inches squared. If one side has that area, so does the other. And then finally, we have the top and the bottom. Now this top, let's say, has that 9, right? And we've got 4 deep. That 4 was the wide, okay? So we've got the top has a 9 by 4, which is 36 inches squared. And that means the bottom is going to have the exact same. Hope you're enjoying Natalie's toy in the background. It's always fun here in Mrs. Young's math class. So we have found the area of every single area, every piece, all 6 pieces. But to find the surface area, we have to add up each of these numbers. So again, what I like to do is add up the ones that are the same. So 45 plus 45 gives us 90. 20 and 20 gives us 40. 36 plus 36 gives us 72. To me, it's easier to add up three numbers, okay? 90 and 40, 130 plus 72. If I add 70, I get 202. So our total surface area would be 202 square inches. The question was, if she had 200 square inches of paper, did she have enough to cover the gift? Well, our gift requires 202 square inches. This teacher only had 200 square inches, so she does not have enough. 2 square inches short. Now we'll never know who the favorite student is. Why don't you guys try out some of those word problems on your own?